This is a video on square roots. It's by vertically and crosswise division. That's a general method of finding the square roots. This video does extend into application of this method to solve a quadratic equation. It does not quite solve the equation, just introduces that this method is applicable to those equations. It's video number 15 as part 5 of 5. I've split the video in 5 parts and this is the last part. Okay, let us continue. Okay, let's go to the next section here. Okay, in this section we'll do square roots from vertically and crosswise divide. Let's continue here. Square roots from vertically and crosswise divide. Let's continue here. Background. What's vertically and crosswise divide? Do you remember doing that before in a previous video? Answer. That is straight division. Straight division is where we split the divisor into two parts. One is divide by part, the other is adjust for parts, and adjust for part goes on the flag. They make the flag digits. Let's continue here. So what do we do in straight division? Okay. In straight division, we have a dividend and a divisor. By dividing, we determine quotient and remainder. So we have, when we were in straight division, we were given a problem in which we had a dividend specified and a divisor specified. Okay. Let's continue here. Sometimes we decimalize the remainder. Okay, instead of remainder, quotient remainder, sometimes we also do a decimalized remainder. Okay. Let's continue here. What are the basics of vertically and crosswise division? Let's see if you still recall what is involved in vertically and crosswise division. Okay, answer, it's divide and conquer. Okay, so we divide the division into two parts, divide by part and adjust for part. From there, adjust for part becomes the flag digits. Okay, so we make the adjust for parts as the flag digit. So if we had example of dividing 886675 by 3102, so what do we do? First we do is 3102 is equal to 3000 plus 102. Okay, divide by part is 3000, which is equal to 3 times 1000. Adjust for part is 102. That one here, 102. So first two subdivision we do, first we divide by 1000 and then by 3. Okay? And flag digits are 102. So we first divide by 1000 and then by 3. So problem setup is like that. Here is my dividend. Here is my divisor in two parts. Okay. Here is a 102 is flag digits and 3 is a divisor, which is the then by 3. And here is that divide by 1000 here. First divide by 1000 and then by 3 again and adjust for by 102. So this is the setup and this is your background for vertically and crosswise divide. Let us see how we are going to use same thing in computing a square root. Let's do a square root now. Okay? In division, we will need a dividend and a divisor. Dividend we actually have. Divisor we will have to find out. Okay? Dividend is given number. Given number we are trying to take a square root of is the dividend. Okay? And what's divisor? Let's find out what divisor is. Okay? Is there any divisor given? The only thing we are given is a square root of, need to find out square root of a given dividend or given number. Okay? So we need to find that out. Square divisor we don't know. From previous section we know that we were dividing by 2 times the leftmost digit. Okay, we know that we were dividing by 2 times the leftmost digit. That will be our divide by part. That will be our divided by part. By the way, 2 times x come from first differential of x squared. Okay? Let's continue here. What's the adjust for part? So we know we are going to use a straight division, which is vertical and crosswise divide. Okay? And we just found out that we are going to divide by this 2 times leftmost digit. Okay? And adjust for part. Let's see what that is. And we also need a flag digits. Let's continue here. In this case, it will grow dynamically. Okay? In this case, it's not a fixed number, but it will grow. Okay? Where does decimal point go to? See, we were dividing in 2 steps. One in the previous example by first by 1000 and then by 3. And division by 1000 gave us a hint of where does the decimal point go to. And where would decimal point go in here? So we don't have a two-step division here, but we still need to figure out where decimal points go. Let's continue here and use first principles to determine number of whole digits in square root. Okay? After we know the whole digits in square root, we can determine where the decimal point would go. We can apply this lessons of the previous section here into determining square root of 35319249. That's 8 digits of the number. Okay? Square root of 35319249. So first we make a pairs in square. We need to figure out how many digits in the square root are. So we get 4 pairs: 35, 31, 92, and 49. 4 pairs. So leftmost digit comes from the table of squares and from 35. So from that table we have 5 is the leftmost digit of square root, and remainder from that is 35. We only used 25 of the 35, and so remainder is 10. Okay? Let's continue here. And divisor would be 2 times this 5. 2 times 5 equal 10. That is our divisor. Okay? We would be dividing by 10. Let's continue here. Now let's set up the problem for division here. So problem is 35. From that we got 5 here. Then 3, 1, 9, 2, 4, 9 are the, we have not used these dividend digits yet. From this 5, I got 10, twice as much as the divisor. And from this remainder 10, that goes with the next dividend digit to make a next dividend, gross dividend is 103. Okay, let's continue here. Now we need to figure out where the decimal point go to. Okay? Number of whole digits in square root are 4. So this 2 digits give me 1. This thing would give me another digit. This one would give me another digit, and this one would give me another digit. That means decimal point would go right in the here. We need 4 whole digits in square root, 4 pairs, 4 digits, whole digits in square root. So that's my, so we just divided by 1000. That's basically, and this decides my decimal point goes right here. So make the position of decimal point. Then I just mark the position of the decimal point here. Okay. Problem so far is first quotient digit is 5, divisor is 10, and remainder is 10, and we have 103 for gross dividend. Okay, let's continue here. Next gross dividend is 103. No digits on the flag, and net dividend is also 103. Let's continue here. So 103 divided by 10 is, we will use 9, remainder 3, 13, which is altered remainder. If we did use 10 remainder 3, that would advance my first digit to 6, and which violates my first principle. So 9 remainder 13 is what we are going to use. Okay? That means 9 goes on the flag, 9 goes in quotient digit, and 13 goes as a remainder which gets added, appended to the next dividend digit. Okay? You see that we also added same digit to the flag also. We got 9 here and 9 here. Let's continue here. You recall from previous section we were subtracting duplexes. This setup would do the same thing. Okay? Adjustment to the flag would be 9 times 9 is 81, which is the same thing as duplex of 9. Okay. Now we have next cross dividend is 131. We would be adjusting that. Okay. Let's continue. Cross dividend for next is 131. Here. Okay. So next cross dividend 131 from previous slide, and adjustment is 81. Let's see where did that come from. It come from 9 times 9. This is my vertical and crosswise multiplication setup. Okay, 131 minus 81 is 50, so we would divide 50 by 10, and we will use 4 remainder 10. Okay, we just alter remainder 5 remainder 0 would be make it a next position little too small and won't be able to subtract whatsoever the adjustments are. Okay, so we'll use 4 remainder. So the 4 here and remainder 10, and 4 goes on the flag also. Let's continue here. Next cross dividend is 109, that's right here. And now we'll adjustments. Adjustment will be 94 times 94, which is a duplex of 94, and this is a cross vertical and crosswise multiplied. 9 times 4 is 36, plus another 36, 72. So 109, that 109 here, minus 72 from here equals to 37. Let's continue here. We will divide by 10 again, is same process. 37 divided by 10 is 3 remainder 7. Okay, 3 remainder 7. We've got 3 here and remainder. 3 goes in here, 3 goes in here, and 7 goes in here. This quotient digit 3, the same quotient digit 3, and remainder 7. Let's continue here. Gross dividend is 72 now. Okay, that is 72 right here. And we are in the section after the decimal point here. So now next adjustment would be 943 and 943. 943 times 943 is a duplex of 943, and we will just figure out what the adjustments are. So net dividend, this give me 70. 9 times 3 27, another 27 here. 27 plus 27 is 54, plus 16 here, 4 times 4, 70. So 72 minus 70 is 2. Okay. Net okay. We'll do a 0. 2 divided by 10 is 0, remainder 10. 2. Okay, let's continue. So that's 0, remainder 2. Okay, 24 here. So next gross dividend is 24, and let's go to 0 here. Continue here. Okay, next gross dividend is 24. Now adjustments. So we get 9430 here, 9430 here. That's duplex of 9430. 9 times 0 is 0, 0 times 9 is 9, 4 times 3, and 12, and another 12, 24. Okay. So now net dividend is 0. So we get net dividend 0, we got 0 remainder 0. So 0 goes in here, remainder 0 goes in here, the quotient is 0 goes in here. Let's continue here. Gross dividend is 9. Okay, now let's adjustments here. So we got adjustments is now 94300 and 94300. So this is 0, this product is 0, this product is 0, this product is 0, and 3 times 3 is 9. Okay, that's my adjustment is 9. Net dividend 0. Yeah, so we got 0 in the end. So that means now we stop. Remainder is 0 and no more digits to continue with. Okay, so we will stop because the remainder is 0 and no more digits to continue with. So square root of 35319249 is 5943, and it's a perfect square. Sections in decimal is, we got our zeros in decimal sections, so it's a 5943.000, which is 5943. Square root of this number 35319249 is 5943. Continue observations. What the observations from a previous section is, we use straight division to find square roots. So we use the straight division, which is we call it vertically and crosswise division. Okay, first quotient digit came from table of squares. Okay, so we use the first principle for the first digit of the square root. The division was double of the first quotient digit, so we started with the divisor came in from first double of first square root quotient digit, first digit of square root. Flag digits came from subsequent quotient digits. As we continue to compute further quotient digits which are in division, which we are trying to square root, so next subsequent square root digits of the answer, then they also went on flag. We continued division past the decimal point section. Okay, we continued this division even after the decimal point was reached. Okay, all quotient is past decimal points were zero. In this example here, everything was zero after the decimal point. So it was a perfect square. We were our example number was perfect square. Okay. Note: VM books do not use the flag digits. Instead, the books use duplex of all the quotient digits except the very first quotient digit. Okay. The two treatments are equivalent. Okay. You use the one you prefer, but this one looks to me clearer that it is still just straight division, which is also called vertically and crosswise division. Now we're going to have an example where it's not a perfect score and its number is 665496. Only you got 6 digits of the number here. We will do the up to decimal, 2 decimal places. Okay, let's continue here. So we'll do a square root of 665496. Let's continue here. We'll make pairs here like 665496. 3 pairs. So they mean 3 digits before the decimal point, and that's 3 whole digits of the answer. Find leftmost quotient digit from table of squares. That digit is 8, and from 66, square root of 66 is a whole number is 8, and then remainder is 2. Let's continue here. So divisor is 2 times 8 is equal to 16. And number of whole digits is 3 from first principle, 6 pairs and 3 digits. Now 3 pairs and 3 digits. 6 number. There are 3 pairs here and 3 digits in the square root. The problem setup is 66, 5, 4, right 6, 8 as my first quotient digit, and 16 is my first divisor, and 2 as a remainder which get prepended to the next dividend digit. Okay, let's continue here. And number of digits, whole digits is 3, so that means that I got 1 digit here and I would get 1 here and 1 here, so that the decimal point would go here. Okay, let's continue. Okay, so problem so far was 66, 5, 4, 9, 6. Decimal point go here. 8 was first digit of the quotient, or first digit of square root, and 16 is our divisor, and 25 is our gross dividend in the next step. Let's continue here. Gross dividend is 25, no flag digit so far. Net dividend is also 25. And divide 16 by 25, divide by 16, 25 divided by 16 is 1, remainder 9. Okay, so 1 goes in here, the quotient digit, and 1 goes in the flag digit. 9 remainder comes here. Okay, net gross dividend 94, adjustment is 1, 1 times 1, okay, which is 1 times 1 here. Is a duplex of 1 is 1, and 1 times 1 is 1. Okay, no dividend digit, net dividend is 94 here. 94 minus 1 times 1, 93. We'll divide 6 by 16. That 93 divided by 16 is 5, remainder 13. So 5 is the quotient digit and 13 is the remainder. So the 5 quotient digit here, 5 goes in the flag and 13 comes in here. Let's continue here. Gross dividend digit is 139. Right here. Adjustment is 10. Let's see where 10 comes from. 10 comes from, it's a duplex of 15. Duplex of 15, it is 1 5 times 5 1, which is 10. 1 times 5 5 plus 5 times 1, which is also 5, and 5 plus 5 is 10. Adjustment is 10. Net dividend is 139 minus 10 is equal to 129. So, okay, so far we had 139 minus 10 as net dividend here. 10 comes from here. 129 is 10 is also duplex of that, and also 15 times 15. Net dividend is 129 divided by 16. We will use 7 remainder 17, not 8 remainder 1. That will get me a negative situation later. So that's altered remainder. We use 7 remainder 17. 7 is the quotient, remainder is 17. 7 would go here, 7 would go here, and 17 would come in here. Let's continue here. So we are at 7, 7, and 17. Okay. So adjustment for next step would be like that 157, 157. Okay. Gross dividend is 176. Adjustment is 39. 7 times 1 is 7. 7 times 1 is 7. 7 plus 1, 7 is 40. And next is 5 times 5, 25. 14 plus 25 is 39. That's adjustment. Net dividend is 176 minus 39, which is 127. Let's continue here. Now we're going to divide again. We would say 127 divided by 16 is, I just use negative number now. 8 remainder 1. Okay. Negative 1. 8 remainder negative 1. Okay. Okay. So 8 goes in here. 8 goes in here. And I'm going to forget about doing any more because we are doing it up to 2 decimal places. We're going to come to the end because we're trying to get 2 decimal places. This is second decimal place, and I'm perfectly happy with using a negative remainder here. Let's continue. So we got a square root of this number 665496 up to 2 decimal places. It's 815 dot decimal 78. Now you can do some exercise here, and square root of fallen to up to 2 decimal places, and some of the numbers might be perfect squares and most of them are not. Okay, let's continue here. Square root of 91681125, square root of 118228800, square root of 2765869, and some more. Let's continue with the next section here. And what I want to discuss here is intro to quadratic equation. I don't want to equations here, solve them, but I'll show you how the relationship to this vertically and crosswise method, division method of square root. Okay, let's continue how we could use the same method we just discussed into solving these problems here. So far in this video we have studied square root of a number. Okay. And that problem is we try to solve for x in x squared equal n. Solve for x in x squared equal n. So in these problems we have determined leftmost digit. This is what we did. The divisor was twice that number, and which is also first differential of x squared equal to x. That is x squared here. First differential is 2 times x. We found first digit of x, and that is what we used for twice of that as a divisor. Now if you change the problem with a times x squared, okay, so x squared is n divided by a, divide both sides by a, that's what it is. Okay, from that we can determine leftmost digit of the quotient and remainder. From this n divided by a, we can determine what's the leftmost digit of the quotient and also what's the first remainder is. Okay, yeah, we just divide by a here. We can also say transpose and apply. Transpose a to the right, and this one multiplied by term become divided by term on the right. Okay, let's continue here. Divisor will be 2 times the a leftmost quotient digit. Okay. Oh yeah, if we do ax squared here and do a first differential, that time 2 times a, so it that would give me the leftmost quotient digit would be times leftmost quotient digit. Instead of multiplying by 2 of the digit, we would be multiplying by 2a. Okay. Differential of ax squared is 2 times a times x. So we get first quotient digit and we multiply that by 2a. That would be our divisor. Okay. We can also determine number of whole digits will be number of pairs in whole digits of n divided by a. So if you need to do how many whole digits there are, we can compute n divided by a and see how many pairs of are in whole digits are in n divided by a. Here, So now we're going to make this adjustment here. Next variation is to ax squared, we would add bx equals n. Now we have quadratic, this is a quadratic equation here. Here we will determine x for by trial and error. So we'll determine x and left side uses most of the right side. Okay. We'll try to find x such that left side uses most of the right side and give the whole digits of parts of x and also a remainder. Okay. We are trying to get a positive remainder when we can. We are more comfortable with the positive remainders. Okay. Let's continue here. Divisor would be 2 times ax plus b. First differential of ax squared plus bx is 2ax plus b. So we determine x and divisor would be 2ax plus b. From there we can continue straight division to find digits after digits, digits after decimal point. So we can use this this method we just discussed, straight division method, to find the other digits after the decimals. Okay. And we intend to keep this equation in a later video. We'll take up these equations in a later video, and here's your introduction so that if you need to look into and try and get comfortable with, maybe you go ahead and work them out. Thank you. References. Okay, our references are Vedic Math Teacher Manual Volume 1, which is a elementary level by Ken Williams. The book is available from vedicmaths.org. PDF form is free and the print form you can purchase. Vedic Maths by Bharti Krishna Tirtha ji, that's the main primary reference for anything on Vedic math. Okay. And Discover Vedic Math by Ken Williams, that's most complete, authoritative, and consistent notation it has. It uses organization is by the sutras and not by topics. Continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Glover used these books in his school, and these are very readable. Vedic Math for All Ages by Vanna Singhal is not as complete as other 2 books are, but this is a very readable and it's a nice way to get introduced to Vedic Math. That is it.